my name's Margaret Fowler, and like Kathy said, I'm a researcher with the Texas A&M Transportation Institute. A little bit about me. I started working at TTI as a student and then a master's student, and now I've been with TTI full-time for the last 4 years with their Systems, Operations, and Technologies division. One of the very first years I was at TTI full-time, I actually got an opportunity to work on a project looking at connected and automated vehicle technologies in motorcycles. We looked at industry practices, academia, but we also got to speak to riders to see how they would feel, if some of these technologies were available to them or accessible to them. But since then, or I guess I should say, prior to that project, my motorcycle experience was very limited. The only real experience I had was maybe occasionally riding on the back of my dad's Harley growing up, and then also maybe hearing some arguments between the parents about said Harley growing up. But after that project concluded, I actually got to present that paper here at the forum. Met a few nice folks, got roped into getting my license, like Kathy mentioned, and now I occasionally putt around in my neighborhood on a dirt bike in San Antonio. It's lots of fun. But that's not why I'm here today, and this presentation isn't necessarily a part 2 of that project, but since that project, a lot has changed in the connected and automated vehicle industry. In fact, I'm here to talk about a new project, also known as the Texas Trust Project. It's a federally funded initiative supported by US DOT. It also stands for Transforming Roads, Unleashing Smart Technologies Project. But the purpose of this project, or should I say deployment, is to deploy connected vehicle technology into advanced connected vehicle technology. There have been several deployments across the country and across the globe, but what makes this deployment stand out is this isn't just a proof of concept or looking at if these technologies are feasible. We're looking to deploy real applications or connected vehicle applications into the real world and essentially just seeing what happens and evaluating those applications over a long period of time. But the 2 key elements, again, that make this deployment stand out are also a scalability factor. Now that wireless technologies have advanced, AI is available, V2X can be more impactful and scalable more than ever, but then also establishing something called interoperable connectivity, which we'll talk more about. But for today's presentation, we'll be talking a lot about the Texas Trust Project, what V2X is, connected vehicles, but specifically why motorcyclists like yourself should care about V2X. So let's get started. All right, so like any good presentation, I think it's always good to start with some basic definitions. Just out of curiosity, who here has heard of the term V2X before? How about connected vehicle technology? How about terms like V2I or V2V? Okay, so a few of you. So essentially, more or less, all these terms I just mentioned are pretty interchangeable. V2X stands for vehicle to everything, V2V is vehicle to vehicle, and then V2I is vehicle to infrastructure. Also, all these terms also known as connected vehicle technology. But essentially what this technology is establishing communication between vehicles, the road infrastructure, and other road users. By providing all entities information of roadway conditions by installing infrastructure and other sensors on the road, we can share that information and alert drivers, road users of upcoming road conditions to alert them to hopefully prevent crashes, reduce congestion, and improve traffic flow by keeping users more aware of their surroundings, improving their knowledge base, and increasing their situational awareness, and ultimately promoting something called cooperative driving. All right, who here has heard of the term autonomous vehicles? Okay, so that seems to be a little more popular, which is pretty interesting. Would anyone by chance be brave enough to potentially answer how those may be different than connected vehicles?
So I'll give it a shot. So I would say autonomous vehicles operate independently of the infrastructure of other vehicles around them. They rely on their own data and their sensors and everything else to determine where they're going to go next and what they might encounter. Connected vehicles would potentially do similar things, but also have connectivity to their surroundings. So take inputs from other sources towards the vehicle. The autonomous vehicle obviously drives by itself. A V2X vehicle could be driven by a person, and just the vehicle might, through its technology, might augment the road user's inputs or inform the road user of what's coming up.
You should join me up here. Yes, that was a great explanation. So like you're saying, AVs work pretty independently. They rely on their own vehicles, equipment, and sensors. Versus connected vehicles, they're receiving information from infrastructure like roadside units installed on the roadway, as well as other sensors. So AVs work pretty independently, while connected vehicles, on the other hand, again, are promoting cooperative driving. Now, you may be asking yourself, why does this distinction matter? Well, I'll give you two reasons. One, increased visibility, and then two, cost. So a shortcoming of autonomous vehicles, since they are relying on their own vehicle's equipment, they can only see as far as those sensors and other equipment on the vehicle could see and what's around them. But versus a connected vehicles, on the other hand, they have farther reach. With connected vehicle technology, we're hoping to install this equipment throughout the transportation network. So even before you or your car or even motorcycle sees a potential hazard or construction or whatever else may be on the road, you'll be alerted. But the second reason is cost. So I don't know about y'all, I hate spending money. And, when we hear about all the benefits of autonomous vehicles, I think what, that industry is really asking of consumers is to buy an entirely new vehicle and to achieve those benefits, completely replacing current fleets of just AVs. But with connected vehicle technology, these messages can be received to little to no cost to the user. There are a few high-end vehicles on the market currently that can receive that type of messaging. There's also been a few apps developed for pilots and deployments to receive connected vehicle messaging. But as this technology progresses, more apps will most certainly come out. And I know that there's being work done at looking at existing navigation apps on how we can integrate that messaging into those. So is VTEX new? No, it's not new. It's actually been documented and studied for several decades. I guess the slow progress really boils down to, the technology available. And I guess what I mean by that is in the, I guess, recent years with advancements in AI and wireless communication, we're able to look at more of scalable deployments as well as deployments that have a bigger impact. But because of these advancements in these technologies, we're also looking at low latency. Messages can be received to users faster than ever before, which we want, especially in safety critical situations like motorcycle riding, where seconds really matter. So what's the current status? Like I said, you know, the equipment is available to essentially send these messages in the air. And then also there's standards developed by SAE, IEE on what those messages contain, and those standards are continuously evolving. And like I also mentioned, there are some higher end vehicles on the market that are capable of receiving these messages. And then finally, while we don't have direct cellular reception, there are a few apps that are capable of receiving these messages. All right, now to the good part, why you guys are here to begin with. Oh, okay, it's still working. Why should riders want V2X? Well, firstly, an improved safety factor. With earlier alerts, we can inform drivers, keep that situational awareness high, and ultimately prevent crashes. Increase visibility. You know, a phrase we talk about often at the forum is, I just didn't see them. Or, you know, in case there's a moonwalking bear walking around, then you know. But yeah, we want to make riders more noticeable to drivers. And a couple of well-established use cases in the V2X world is actually notifying drivers of vulnerable road users nearby, especially at turns or intersections. In fact, one of the use cases in this deployment is looking at making intersections in SPAT-enabled messaging, meaning they are alerted when vulnerable road users are nearby. But then also an improved knowledge base. You know, how nice would it be to get an alert that there's a hazard ahead, or maybe pavement conditions are changing because of construction, weather, sleek pavement, roadway conditions, or even just other drivers. Emergency response. That's actually another use case we're looking into currently for this deployment. Giving emergency vehicles the traffic signal priority, giving them the green light, but also notifying other drivers around those vehicles that they're coming. So if something does go wrong on a ride, you know, those emergency vehicles can get to you even faster. But with messaging capabilities, we're also looking at enhancing traffic flow, potentially sending messages whenever there are emergency events or even special events, and detouring vehicles. Another interesting thought or use case potentially in the future is maybe even providing motorcyclists their own specific detours away from mixed traffic. Yes, do you like that? Feel free to cheer if you hear something that you're like, I want that. And then also cost-effective infrastructure upgrades. I'm sure y'all hate construction zones. They're terrible. They're never clean. But, you know, one, and I am by no means an expert in this field, but from what I hear, you know, the word on the block is, you know, when we expand our corridors or infrastructure, we essentially just end up creating more congestion. But with connected vehicle technology and keeping the roadway informed, rather than thinking about expanding, we're thinking about efficiency. So again, just kind of driving the point home, this figure was developed in another project, so might be a little outdated with some of the labeling. think of V2X or connected vehicle technology as another layer protecting you from the environment. You know, the closest layer being that personal protective equipment. Then you're looking at ARAS, or advanced driver or rider assistive systems. And then that exterior bubble, or most outermost bubble, connected vehicles or V2X technology. You know, picking up on things that maybe human senses don't always pick up on because of our limitations and perceptions. Okay, so going back to trust, what's it all about? We are hoping to deploy 15 use cases, and not just deploy, operate, and document and showcase V2X and its capabilities. But we're not just trying to achieve connectivity, we're trying to achieve interoperable connectivity. Essentially ensuring that all the devices, systems, and people in place needed to, I guess, keep V2X running, those communications are seamless and work effortlessly together. But one of the better examples I like to use to really drive this point home is cell phones. Raise your hand if you have an Android. Now raise your hand if you have an Apple phone. All right. So notice I kept my hand raised for both because some people feel really strongly about that. If you're an Apple user and you get a text from an Android, what happens? Turns, what color? Turns green. Or Android user, if you are added to God forbid, a group chat, it's a hot mess. Every time someone likes something, you're getting notified. You get double messages. What else? Or a separate message. Yeah, I forgot about that. Or if you get like a video from an Apple phone, it's usually blurry, right? Yeah. It's horrible.
That's because all my children had iPhones.
That was the reason I switched over.
How dare they? Well, see, just because we have two different phones, we're seeing all sorts of communication issues. And we don't want that on the roadway. It shouldn't matter if you're on a motorcycle or in a car, or if you're driving a Ford or Hyundai, Nissan, so on. We want to make sure that all the systems in place and all the messages are of such a standard that it doesn't matter what vehicle, what brand, manufacturer you're in, you are going to receive the same high quality safety message as the next person. Or, another example, if I'm in Texas and I'm driving to New Mexico, for whatever the reason is, whatever message I receive in Texas should be the same as if I'm in New Mexico. The quality of safety and messaging should be held to a high standard and should be consistent so it doesn't confuse the public. So our major project goals are, one, to deploy these use cases so we can improve safety, efficiency, mobility, and potentially reach maybe some underserved populations. But another important aspect of this project is the education and outreach. I mean, by show of hands, I think we are more familiar with the term automated versus connected, and often there's a lot of misconceptions on which is which. So that's another major portion of this project. But even bigger picture, ultimately this project and all its findings and insights are meant to inform a national blueprint. So not only can V2X be available in certain states, but available nationwide. So right now, in the project schedule, we are split up into 3 phases. We have our design, our operation phase, and then our evaluation post-deployment phase. We're in about month 6 right now. We actually recently just submitted all of our systems documentation, and by around this time next year, spring, early summer, we're hoping to deploy about 15 use cases or 15 applications of V2X. But more importantly, I think the most important phase of this project is actually the post-deployment. You know, how technology is used day 1 is always very different down the line. Sort of like how riding day 1 is super different than year 10. So in that evaluation phase, you know, we're hoping to see if there are ways to make these systems more efficient, hopefully collect feedback from the public, and maybe address any technical difficulties. So as far as deployment region, like I said, we're deploying 15 use cases. There are some use cases that will be deployed in the city of College Station, the city of Houston, and then some in between. Now, the use cases selected for each area was not by accident. It was very intentional based on current capabilities of that region, but we also wanted to make sure that we were addressing real needs of that area. Like for instance, in Houston, one of the use cases is looking at hurricane evacuation and incident response. I mean, how many hurricanes and floods have we had in Houston the last couple of years? Quite a few. But then even in city of College Station, if any of y'all are familiar with Aggie or football in general, you'll know that town completely changes overnight if there is a football game. I remember the first year I lived in College Station getting stuck in game day traffic, and I was shocked. I could not believe that many people could be in one small place. But that use case, again, is focusing on, you know, if there's a special event, how can we notify vehicles so we can, you know, reduce congestion and make sure that everyone's sharing the roadway safely. All right, so back to motorcycles. That's why y'all are here. What are the relevant use cases to the motorcycling community? Well, as it stands, you know, these use cases that we are deploying are driver-focused or driver-facing. But that doesn't necessarily mean that motorcycles are left out of the equation here. In fact, in our outreach plan, you know, we had to identify all the different audiences we would like to reach, as well as who would have an impact on this system. And it was very deliberate that it wasn't just vulnerable road users, parentheses, motorcycles, you know, you guys are your own distinct community with your own distinct needs. But for now, you know, some of the use cases, you know, will definitely provide safety benefits to riders by influencing other vehicle behavior. You know, like I mentioned earlier, looking at enabled intersections to inform drivers of, you know, a vulnerable road user nearby and to hopefully look twice, or vehicle preemption like we talked about, or even reducing congestion given an emergency event or a special event. But some of the other use cases that I most certainly foresee applying the most to motorcyclists in the future are things like curve speed warnings, or even planned construction, adverse weather, wrong way drivers, or even one of my favorites, the red light indication. So essentially, you're approaching an intersection, and then you're notified that the light's about to turn red. And the reason why this resonates with me is I actually had a friend who was a new rider, and when he was approaching an intersection, you know, let the right light turn red, and he was close to crossing. Had 2 options, either to go or to stop. he got spooked, stopped too fast, and ended up crashing. So I definitely think that through all these use cases, there's a lot of future opportunities for riders. But one of the main challenges in implementing these use cases is how are we going to get messages to motorcycles? You know, y'all are working with a limited real estate versus vehicles. Should these alerts be auditory, visual, through your helmet, GPS device? Because a lot of riding is about staying situationally aware. But if you have something beeping in your head 10,000 times that there's a driver nearby, you're just going to turn it off because it's annoying and it's going to take away from the true safety benefit that connected vehicles have to offer. So, you know, there's still work to be done in that. And like I said, your own distinct community with your own distinct needs, and these definitely deserve time and consideration on how to alert you. But outside of trust, you know, there's actually a lot of folks working on connected vehicle technology in motorcycles. And if you guys would like a link to this website, please come up to me after the presentation and I'd be happy to direct you. So there's a group called the Connected Motorcycle Consortium. They're a group of researchers, suppliers, vendors, manufacturers, who essentially have dedicated their time to coming up with a variety of use cases for connected vehicle technology in motorcycles. The one up on the screen are just a few examples, but their websites provide several, I don't even know how many, it's quite a few, use cases, their descriptions, as well as video demonstrations. But even more importantly, they have been working on more of the technical aspects of things. You know, what are the technical requirements to have these technologies in motorcycles, or the operational requirements, or the user requirements. So this work is definitely being pursued currently.
Those are actually pretty cool. That's pretty cool.
Do you guys like these? Are there any ones in particular?
It's the whole idea that, if I'm reading it right, it's giving the drivers of the car the information that that rider is there.
Correct.
That's pretty awesome.
Correct.
About the teaching kids to look for
Right.
these things, that's actually really cool.
And it almost raises the question too, if they were more alerted about other motorcyclists nearby, even if they didn't have it, would their mental model change of the road?
Absolutely.
So, a lot of great work.
Our brain tells us what to see.
Exactly. But rather than me, or anyone else for that matter, you know, tell you what you need or don't need, I think it's really important that this remains a two-way conversation. In that FHWA study I mentioned earlier, you know, we got an opportunity to host 2 focus groups. Some of those riders actually might be in the room today. But in those 2 focus groups, we talked about connected and automated vehicle technology in motorcycles. And we're essentially asking riders, how do you feel? Would you find these things useful? What feels promising? What feels concerning? And I think the results from those 2 focus groups are very much still relevant today. You know, we were even talking during Kathy's session, if these technologies are available, will there be an over-reliance? Drivers just not looking anymore because they're expecting an alert. Or even new motorcycle riders. Like we talked about, you know, that situational awareness, keeping your head on a swivel is really important while riding. And if novice riders are given these technologies, will they not build the same skill set as experienced riders? And I think that's still a really valid point. Or even just generally, user acceptance. You know, I could be wrong, but I'm pretty sure I read an article, you know, when anti-lock braking first came out, there was a lot of pushback. And it took some time to build trust and for riders to really see the value before that was accepted. So we don't really know what that would look like with connected vehicle technologies once deployed. But what felt promising, on the other hand, was actually faster reaction times. You know, I think we always talk about trying to find your escape route, trying to be prepared, overly prepared for anything to happen. You know, connected vehicle technology through communications could potentially give you that extra preparedness or that extra time to react, or even prepare you for some unforeseen, critically safe or unsafe scenarios. So that's really all I have for y'all today. We'll definitely do questions here in a second, but you know, if you guys are interested in receiving more updates about this project, we don't have a website yet, but we're hoping to have a public-facing website in August or September, or this coming August or September. And if you're interested in receiving that link, you know, I also have business cards, or you can write my email down, and I'd be happy to forward you that whenever we launch our website. But otherwise, you know, I'll most certainly take questions, but also comments. You know, a big part of this project is the outreach, and that means identifying things that resonate the most with folks. So if you have any comments you would like to share, I definitely welcome those, and thank you all for your time.
So Mercedes-Benz and Volvo are two automobile manufacturers that kind of lead the way in safety. And of course they apply technology and automation to like radar blind spot assistance, radar-based cruise control. We're starting to see that on BMW motorcycles as well. Do you foresee connectivity and automation merging to where crashes are completely, almost like, you know, may the force be with you, where to prevent collisions between vehicles, where vehicles are sharing data so rapidly in real time, and they're sensing that they're coming upon each other, that they can actually both stop without your necessary intervention, or maybe you can't react, maybe it can react faster. Is that a possibility, and is what you're studying headed in that direction?
So I just want to make sure I understand the question. Are you asking if I foresee connected and automated vehicles converging into one?
Right, to where they're sharing data so that automobiles can avoid hitting each other, because they're sharing data and leveraging the strengths of both technologies to prevent things from happening.
Well, I do see those two things converging. And in fact, you know, in research, we often use the term CAV, meaning connected and automated vehicle. But sometimes it gets confusing in, you know, working with other agencies or even the public engagement side of things, because technically they are two separate concepts. But I definitely see both converging and going that direction. I think what will make it challenging is that we have all these automated vehicle, you know, companies, manufacturers, and USDOT is really pushing for connectivity. So I see the complication being, you know, how to merge industry and federal agencies, which is probably a tale as old as time. Thanks, Laura.
Hey, so this is pretty cool. So I'm curious, in your trial, in your test or pilot, are you doing simply V2I, or are you doing like V2I to V, or are you also doing V2V?
So some of the use cases. So I guess that's what we're trying to sort out in all of the technical and system engineering documentation currently, because every use case, I guess, has its advantages and disadvantages. Each use case has more maybe established capabilities and then less established capabilities. So some use cases, I can't name them off at the top of my head, are more focused on, I guess, just admitting the message, but it not necessarily being received by a user. Some use cases, there is the ability to send that message and for the user to receive that message. And we're actually still talking to a few vendors on, what mobile applications we could use to potentially display those messages. So I would say it's definitely a combination of both. I mean, the end goal is to hopefully send a message to all users, right? But again, it kind of depends on, the technology available and the use case.
All right, so the question I have has to do with the actual message being sent. I'm assuming that each vehicle will have a limited range of transmission of information. Are there going to be the equivalent of repeater stations or a cell phone tower type arrangement along the major highways in order to pass information far enough ahead for these two vehicles that are approaching each other or the unseen vehicle?
So there are a variety of messages that can be sent and received. And some of those are basic safety messages, or, and I can't recall all the acronyms off the top of my head, or what they call SPAT-enabled messages, or essentially information about the roadway geometry or pavement, and then basic safety messages. So there are a variety of messages that can be sent and received, but I guess to answer your question on the signal and how far these messages go, I think that's part of this deployment, is evaluating how far could we push current capabilities and what could we set up to hopefully set all these messages up to be received from a wide ranges of distances.
What you have to do, it seems to me, what you have to do in the case of, say, the road construction or some obstruction ahead, you have to have a system for monitoring that and passing that information on. And that would be different than his car and my car talking to each other as we approach each other.
Right.
So where does that information come from? Who monitors that and provides that information as opposed to car-to-car communication?
So I actually really like this question because recently we had a big discussion on the differences between, V to X and digital infrastructure. So digital infrastructure is essentially referring to just that. There's sensors and infrastructure installed on the roadway that are used for a variety of reasons, whether that be to potentially adjust tollway prices, or whether that be to close a lane and then redirect traffic. So V to X is just a component of general digital infrastructure. And a lot of what you're talking about is looking at, asset management. So a lot of districts and also cities oversee those sensors. And I guess that is part of that interoperable connectivity, is how do we align stakeholders and current infrastructure installed to make sure that communication is seamless, but also to make sure that everything is being monitored and evaluated. Any other questions? Yes.
The V2V thing seems great, especially for a motorcyclist, to know that I am a vehicular entity as I approach an intersection where someone's waiting to make a left turn. But I also envision it becoming everything like V to I, and that a DPS officer sitting at a computer in Austin is writing me a ticket for going 85 miles an hour west of Amarillo, and I'm just trying to get away from the stink of the feedlot, you know. But is in the user, in the section where you said user acceptance, is there anything, someone looking at privacy concerns? Other than our legislature, of course.
Yeah, so a big...
Oh, there you go.
Actually, a big component, a big component of this project and working with USDOT is they are very particular on what messages we are trying to send out to the public. And one of those messages is that connectivity is supposed to not only come to little at no cost, that was a big message, but this other, I would say even bigger message is addressing privacy concerns. You know, a lot of the data that is being collected on the roadway, even through, I don't know all the technical specs here, but even through larger data sets, you know, every time it's talked about, I would say that everyone's very careful that this is anonymous data and there's nothing, I guess, no personal information that would trace you back. So I think they are adamant that data will continue to be private. I guess I might need to get back to you on how that is anonymized. Questions? Well, if there aren't any other questions, again, really appreciate everyone's time. I'll definitely stick around for a little longer, and if you would like to have more of a discussion or, again, talk about some things that really resonated with you as an end user, I'd be happy to do so, and feel free to reach out to me. Thank you.